Okay, everyone can see that.
Yes, betul.
Okay. Okay. All right. So I think in our last lecture we talked about we stop it here in port, right? And so I will continue from here on. Let's see our port. There are 4 ports here. Okay, and there are 4 ports for ATMEGA32, and it's important for us to know the things that we need to know. In terms of port, okay, when we talk about ports, meaning that when we communicate with other, with the external, with the other environment, the external uh, um, ambience or environment, we need to connect it to some devices, right? So we need to use data direction register (DDR) and port, okay, as well as pin. Okay, please look at this. DDR is used for data direction register, okay, for port. Meaning that we need to identify what is the okay, for the ports we need to identify, or we need to assign the port as whether it works as an sorry, man, whether it works as an input or as an output. Okay, so whether it works as an input or output, we define it later on. Okay, so let me write here, over here. I hope. Okay, so for DDR, okay, we have DDR from DDR-A until DDR. Okay, we have DDR-A, DDR-B, DDR-C, and stuff, and DDR-D. Okay, so DDR-A, DDR-B, DDR-C, they need to be told. Okay, we need at first, when we want to use the port, we need to define what is the direction, whether to read or to write in port A. Okay, so meaning that when we use port A, port B, port C, port D, we need to use also DDR-A and DDR-B, DDR-C, meaning that we need to use this register to define it. What is it used for? So like I told you last time, okay, port A, we want it to be as input. So DDR-A must be assigned with an input, meaning how to make it an input. So all the bits are as an input, right? So for example, over here, DDR-A, and there are 8 over here. So we say that, okay, all port A, we will be using all port A as an input. So we need to give 0, 0, 0, 0, 0, 0, 0 to all these bits, right? So what we give is 0, 0. So that tells port A will be working as an input. All right. Whereby if we assign, for example, DDR-B equals to FF, what does it give? It is assigned as an output, meaning that we will give whatever value from our microprocessor, we output it, we give it to a port B. Okay, but for DDR-A, we use it as input, meaning that we read from the external, meaning, for example, we read from switch, we read from sensor or something over here in port A. Okay. Okay, so if it is used as a port B, meaning DDR-B need to define as a need to be assigned as FF first, meaning that we tell them, we tell port B, you work as an output. So port B over here will receive whatever signal it receives from here. Okay, for example, this is port B. So we receive external input from port B. Okay, so we need to define port B first. What it works as. Okay, so if it is DDRB for this work, we need to make it. We need to assign it as 1, right? For all bits, right? Okay, so remember, if you want to use if you want to read from the external port from external device or from external meaning that we want to read, okay, we use port okay, we use port to read. Okay, if you want to write, meaning that we want to write out whatever we write in our microcontroller, we use pin. Okay, so if this is port A, this is pin B, for example. Okay, pin B. So this is pin, this is port. Okay, for port we out. Okay, we give it as an out. Okay, for pin is we use it to read. Okay, to read from is it it's the other way around. Okay, it's the other way around. Pin is used to read. Okay, port is to write, meaning out. Okay, how can I delete? Is there anywhere I can delete it? Interruptions, what actions? Eraser. Okay, good. So I have eraser here. Okay. Now I cannot write. Okay. So again, okay. So to read, meaning that we want to read what from the external environment, we use pin. Okay, we use pin A, pin B, whatever pin. Okay, like this pin A. But to write out our results, and we want the LED to light up, for example, we use port. Okay, port B, for example, something like that. Okay, so let's move on. Okay. So this is how it's been done. So like I mentioned, if we assign 0, meaning 0 to that particular port, so it will become that port, that particular, for example, if you look from bit here, port A, if we define inside port A, okay, this is port A0, okay, bit 0, bit 1, bit 2, until bit 7, right? So bit 7 here means that port A7 will become as input, because we in DDR, because in DDR7, okay, DDR7, we assign it as a 0 over here. That meaning that we want it to work as an input. So in port A, it will not write, but instead it will read. Okay, it will read from the port, from the particular bits. Okay, the port bits, right? And how about port DDR6? Okay, meaning that at bit 6, it will work as an output, right? So we write the output, and then it will give the output. And if you connect it to LED, we will see some results, meaning light off or light on, right? Okay, so you can see from here. Okay, please familiarize yourself with this. Is what we call as assembly language. And this is an instruction set for ATMEL. Okay, for ATMEL. Okay, so we'll see after this, right? Okay, and okay, again, I clarify, writing a 1 to a bit in DDR makes the bit of port something. So let's say, for example, DDR-A, so we make the port, okay, the particular bit in the particular bit in port A as an output. Okay, if you write DDR-A equals to, we want, like I just told you, FF, it means that we're giving all port A as an output, right? If we write in 00, for example, it means that port A will work as an input. Okay. That's all for you to know. So I think it's the same. Okay. And this is the pin operation, pin out descriptions. Meaning that when we read, okay, this is your microprocessor inside here, and it's how it is being read. Okay. By default, it is open like this. Okay. Sorry. So this is outside. Okay. Outside. This is outside, and this is the inside of your AVR. Okay. Okay, so by default, when it reads, okay, your port is connected to pin, right? But by default, if you connect it to the port, to the pin over here at the external device, so at the pin or the port of your microprocessor, okay, your ATMEGA32, what it will do is actually it will read, okay, it will read because port is by default is open. Okay, it's open meaning that it's not connected. So you define it in DDR. DDR you say that, oh, please work as an output, so then it works. Okay, as an output, as an yes, output. Okay, so please remember this high impedance circuit like this. Okay. This one is to simplify your understanding. When you define, this is a buffer, not inverter, buffer, because there's no bubble at this high state buffer, right? Because it's like this triangle over here. So there's no don't bubble means it's an inverter. It's a buffer, not an inverter. Okay, so please read through. I think everybody understand this now. Okay. Okay, I have highlighted this one also, 2 kilobyte, 1 kilobyte, 32 kilobyte flash. And okay, somebody asked, oh, why when we count it's 60, it's 16, okay? But you see that because it is counted in bytes, but in fact in flash it is the memory is stored in words, right? So that's why you actually get 16 kilo words, okay, flash. Okay, remember SRAM is for data and flash is for program. Your meaning your code is stored here in flash. Okay. Okay, and please remember also there's how many memory models here, how many memory partition are inside here. So again, flash is for your program, data memory is for the data that your program writes, right? Your program defines whatever data value it will be stored over here. Okay, so you have general purpose register. Okay, so now it's important for you to know that general purpose register has 32 type of registers. Okay, and then okay, and it started from zero. It starts from zero. Okay, of the data memory, and as 1F. Okay, why not 32? Or not, why not 31? Because this is hexadecimal. So, okay, please go back to your digital electronics to understand how to use hexadecimal. Okay. And yeah.
Saya nak tanya soalan.
What? Yes.
Untuk yang pull up register tu kan. Kalau
Can you use English so that your other friend understands this?
For pull up register,
Right.
dia for input one is mean for close. Then we can program it as whatever we want, right?
Yes, it's like this. Okay, when you use pull up resistor, okay, by default when we connect when we first program our microprocessor, we depending on how we want it to be, okay, how we want our microprocessor to be, okay, we want all the ports to initially works as a active low or active high. Okay, so by default, okay, so if you want it to be active low, right? At first, you want all the ports to be closed first, right? So that depends. If you want it to be active low, meaning that active when it is only low, meaning by default you have to make it what? High or low? at the start of your program. You want to close it.
Low.
No. So you
High.
okay? Please, of course, not low, then high lah kan. So it's like that. So if it is please understand this. When we say active low or active high, okay. So this is a basic of your the basic of your of this program lah. Okay, active low and active high, right? So you learned this before. So please check back. Okay? When we say, okay, please design a circuit that is active low, or port A that is active low and port B is active high, so you have to know, okay, you have to know what to program at first. Meaning that when we say port A is active low, meaning that your by default when you start the program, okay, you need to, if it is active low, meaning that it's active only when it receives 0, meaning that you need to turn it off first, right? How to turn it off? You give a pull up. Meaning when you give pull up, right? You connect it to VCC. Understand? You want it to turn off first, right? Do you understand this? Okay, so okay. Anyway, so I want this to be I want you guys to be maybe you can discuss among you guys, okay? And because it's important for you guys to understand active low and active high, okay? Only when you understand, you can design this pull up or pull down. We have pull up and pull down resistors, meaning that, okay, this one is only, by default, this is pull up, but you can actually make it a pull down, right? So if it is active low, should it be pull up at first or pull down? Okay, so that one is you guys should know, okay? So please, that one is I make it as a homework for you guys. Okay, so it's very important, very very important. Okay, so I'll just continue here. All right, 64 I/O register. Okay, because there are this is the start of the register, the start address of I/O register, and this is the end address of the 64 I/O registers. Right. I hope you guys also have studied this, how we got it. Okay, how you got this address, and you can verify that this is correct. Okay, we start from 20 and then all the way until 5F, get 64 registers, or 64 stack, like racks, right? Something like that. And then you have, where's my pointer? Okay, this is GPR, general purpose register. Okay, so you will see that later on. I will show you in my admin studio. And then this is I/O registers. This one is to use, okay, we can only touch these registers. Okay, to play around in our program, you can only touch this GPR. Okay, 64 I/O registers, we cannot play around with that. You cannot touch any part of the between 20 and 5F. You cannot write any memory here. You can actually, there's a way to do it, but it will actually disturb the program. Okay, it will actually disturb the program, because each address in this I/O register will be used as input output. Okay, meaning that if you write your port A as an input, and then and suddenly you write something at that address. Okay, for example, address 20 is for port A, is for port A to work as what? DDR, to define it as input or output. Then suddenly you write in your program, I want to use memory 20 to store something. But you are actually overwriting the value in 20. So what does it mean? What will happen is that that I/O will not work as we define it to be, right? So that's important, not to avoid, not to write anything between 20 and 5F, right? But other than that, we can use this. For example, internal RAM, starting from address 60 all the way until overshoot. Okay, we stop until here, right? From 60 until RAM, and this is called RAM N. Okay, not ramen, RAM N, meaning that N address of RAM. N of RAM. Okay, why does it write RAM N like this? Okay, because different architecture has different size of RAM, right? So if you remember, right, the RAM is different. So that's why RAM and address of the RAM are different. This is a general architecture for ATMEL microprocessor. So for many ATMEGA processor, ATMEGA8, ATMEGA32, 64, 128, 128. But for what unique about 32 is that we have 2 kilobyte of RAM. Okay, for others they will be having different RAM. So okay, RAM N. Okay, so please remember this one, RAM N. Okay, RAM and address. Okay, okay. Flash memory, like I told you again and again. Okay, many times already. 32 kilobyte, 16 kilo of 2 byte words, meaning that 16 kilo words. Right? So what is the use of a flash memory? You understand already. EEPROM is for, okay, you also already mentioned about it, and then so you should know it now. GPR, the data memory now. We're looking at data memory now. Okay, we just look before this, and then okay, now we detail it. Okay, we detail it out. Okay, let's see. What is the size of this general purpose register? There are 32 of registers. But what is the bit? Or what is the width? The width is 8 bit. For data memory, the width is 8 bit, right? Meaning that at one time, there's only 8 bit or 1 byte of value can be stored at each rack, right? So there are 32, okay. And in ATMEL Studio, you will see the registers are written in this way: R0, R1, R2 until R31. Okay, but in memory, in data address space, you see it is been written as 000, all the way until 01F. Okay, and then starting from 20 until 005F, it is for I/O. Okay, for I/O. Okay, you see, there's a name for it, particular name for it. They are all very unique, and they're being used to assign I/O. Okay, so you cannot actually write anything here because you don't want to override whatever value over here, because you don't want to the program goes chaos. The program goes chaotic. You cannot trace what happened. Okay, and then this is the RAM, meaning that this is the data that when after we do some processing. Okay, usually general purpose register is to use the processing, right? This is where the CPU assess the value. Okay, meaning that, for example, if it wants to do addition and subtraction, multiplication, logical shift, whatever, it will find the value here in GPR. CPU will find the value in GPR. Okay, it does the processing, and then it will store maybe back in GPR, or it will also store direct to RAM. Okay, you will see the instruction set after this. Okay, and to use RAM, the memory starts from 0060 until 85F. Okay, so please look at our is it 2 kilobyte or not? Okay, is it 2 kilobytes of RAM? Okay, please count it. It's supposed to be 2 kilobytes. Okay. All right, so there are three partitions in data memory. Okay, general purpose register, I/O or SFR, special function registers. Okay, special function registers or I/O registers can both are understandable. And general purpose register, okay, the technology that is used, it uses static RAM, SRAM. Okay, or you can just write SRAM. Okay, it's understandable, meaning that it's RAM. Right, so please rate this. Please rate this also. Okay, this one I've mentioned. Okay, what important here is that in this slide, okay, what important for you to know is that R0 until R15 is usually, if you write in ATMEL Studio, you cannot write. It will say invalid data register because usually R0 until R15 is used for instruction set for to store some value, to store some value in instruction set. Sorry, by the instruction set, right? For example, R0 and R1 is being used by multiplication. When you do multiplication, by default, it will store the results in R0 and R1. Okay, so this one is untouchable. Okay, you cannot write it. You cannot write anything here, but for the sake of understanding, it means that it's okay to use R0 until R31, meaning that the whole range of registers can be used. But actually, when you run in FL Studio, you cannot. Okay, and this is the address, right? This is 1F, supposed to be 1F. 1E, 1E, 1E. This is F15, sorry. This is correct, F. This one 1F, alright. Okay, so when you write your code, okay, you start from R16, okay? This one, when you write the code, okay, you can start from R16, meaning that, for example, you write something, load immediate R16 with value 10, for example, you want to write hexadecimal 10, okay? This one, when you have this sign, or this sign, it means hexadecimal, okay? When you write this is binary, okay? And then you write in binary, okay? You cannot write this one you define as binary, but you write in hexadecimal, okay? You cannot do that. Right? It will understand differently. For example, if you write, for example, like this is 10, what will it understand? Will it understand 10 or will it understand 2? Somebody?
2.
Sorry, doctor, can you repeat again?
Okay, this is binary. When you write the code in binary, for example, you put it something like this: load R16 with binary 10. Will it understand as a binary 10, or will it understand it as hexadecimal? Hexadecimal 0A or decimal 10?
Binary.
Binary. What value will it store?
2.
2. Okay. Yes. Okay. So in fact, it will change it to hexadecimal, but because hexadecimal below 9, right? Below 10, they are the same with a decimal, so it will store 2 inside. Okay. Because it is 2-bit, right? And because it is 8-bit, so I will not accept if somebody just write 2 like this, because it seems like you only understand this is 4 bits. Okay, where 8 actually needs to be 8-bit, right? So one hexadecimal represent 4 bits, right? So you need to write it in hexadecimal 8-bit. All right. Okay. Shall I continue? All right. So I shall continue R16 until R16, R17, 18, 20, until 25. Right, and suddenly starting from us to R26 and R31, you can actually also write anything until R31. From R16 until R31, there's no problem. Okay, there's no problem about it. But for your caution, okay, please take precaution to know that R16 and starting from R26 until R31, they are being used as a pointer, memory address pointer. What is pointer? Okay, if you imagine if you can recall your C programming, you have pointer, right? So this pointer these registers are used specifically to store the address of the pointer in SRAM, in the RAM, where we want it to, if let's say CPU want to access a RAM address, RAM address, it will use pointer. So it will use pointer. So pointer will store, pointer here will store the address of the memory SRAM, okay, of the SRAM memory, okay. So that way it will be faster, okay, it will be much faster for the CPU to access the RAM, right? So let's see. So there are how many pointer memory here? So there are three. One is X, one is Y, one is Z registers. Okay, X, Y, Z. When why they occupy two? For X, for each register, why do you occupy two registers over here? Because to store address, okay, address is 2 kilobyte, right? Address of RAM. What happened? Okay, so address is 2 kilobyte, right? So the strings, a string of you need to occupy more than 8 bits, more than 8 bits. So okay, if you calculate that, so you need to have 4 hexadecimal, which is 16 because it's, yeah, we know because it's 16 bit, right? So 16 bit, so you need 4 hexadecimal. So this one will occupy 2 and 2. Okay, for example, let me write 0310. What does it mean? Okay, it means that this X register stores the memory address of 0310. How it is being read? Okay, the higher register will save the high byte, meaning that like MSB and LSB, right? So R26 is for LSB, least significant byte. Okay, this one is byte. I know LSB is for bit, but we use it as byte here, LSB, and this is for MSB. Same goes like this one. Okay, this one for X, this one for Y. For example, memory address 0A, 0, 1, for example. So what Y stores? It stores memory address of 010A. Okay. So when CPU wants to read the value inside SRAM, it will go to Y register, and then Y register will tell, oh, please, this is the address. So in SRAM, it will access this address and then get the value in SRAM. For example, if in SRAM is A1, okay, so SRAM will, and then CPU will take this value A1 and then process it. Okay. Okay, so these are the things, these are the details of it. So when you write the code, you see if you see SH and XL, it means that this is the high bytes and this is the low bytes. Okay, the low bytes, for example, is 1B, 1A, meaning when we combine it, it means 1B, 1A. Okay, so this is the memory. So this is the address of what happened?
So I think that's a shortcut. You can press Control.
Okay, so this is 1B, 1A. Okay, 1B, 1A. The address is 1B, 1A. Okay, things like that. Okay, so YH, YL, and okay, and one more I want to highlight. Okay, so if you write SH, there are two ways to define it. You can use SH. By default, it understand automatically it is R27, and if you write XL, it is automatically understand double as R26. Okay, so okay, later on we see this how to write this code. But you can also explore on your own. Okay, it will be interesting for you to know this in advance before I teach you. Okay, and this is a special function register. So the memory address starting from 20, okay, until 5E. Okay. Okay, this is a stack pointer. Stack pointer. Wait, let me check. Where is it? Okay. Stack pointer is being used here. Okay, why is it important to know? We will come to this chapter later on lah. Okay, it's enough for you to understand that there is a stack pointer address over here. Okay, stack pointer high, stack pointer low. This is to store the address of stack pointer. Okay. What does it do? It is used for storing temporary data. Okay. Oh, what's the difference with GPR? General Purpose Register. It's actually, oh, isn't it the same? It's actually different. Okay. Stack pointer is used to store temporary data when there is a function that is being called by the main function. Like currently, you are executing from line to line, right? And suddenly it needs to jump to let's say line number 100 or number 150, for example. You are currently at address 50, but suddenly it needs to jump. It's like calling a function in C program, right? In main call function, then it needs to jump to some memory address, right? So it needs to store the current context. Okay, well, context means the current value that is executing, because when we return, when after the function is finished executing, you need to return back. When you return, you need to get back the data that you temporarily store. So this is where stack pointer comes into the picture. Okay, this is where stack pointer is used for. Okay, to store temporary data for a temporary execution like that. Okay, so we'll come to this in our final chapter of stack point of assembly language. Okay. Program counter. Okay. I hope you know this already. We've talked about this since our first meeting. Okay, done. So for this, there's also another one is status register, right? Status register is 8-bit status register, and each bit represents a flag, right? You know about this flag before in digital system. So please study this chapter. Please study this slide. I will not cover this, but I will ask you to understand all these status register, and we will cover in test later. Okay, so please study this, guys. Okay, so let's go to our quiz. Okay. Very good. Okay, guys, please go to this form in the chat.
Sir, for some reason it says it's no longer accepting responses.
Huh? Oh, wait. I need to maybe change something over there. Where is the... I need to... No longer. Let me go to my form. Alamak. Wait. I forgot where I save it. I need to open. Let me stop sharing. Let's get the question. Responses. So the answers. List the partitions in data memory. GPR, SFR, and SRAM. Okay, good. Many of you understand that. I don't know. Many of you. Okay, yes, good. Many of you remember. Not many actually, but well, okay. So the answer is GPR. Okay, General Purpose Register, Special Function Register, and SRAM, right? Or IO register. If you write SFR as an IO register, it's also understandable, right? Okay, so good. So many of you are still okay. What are the start and end addresses of SRAM? The start and end address of SRAM is we start from we start from 06. Okay, this is good. 60 until 85F, right? Okay. If you just remember 60, you can also still, if you remember the start address is 60 and you remember the end, the memory size is 2 kilobyte, you can calculate from that, right? You don't have to remember the start and end. Okay, you just need to remember the size and the start address. That's all. Okay. All right. So this is the answer. 60 until 8085F. But this is supposed to be the correct one lah, because you put dollar sign in front. They want to indicate it is in hexadecimal. Right? What is the width of the data memory in bits? It's 8 bits, correct? It's 8 bits, okay? It's 8 bits, right? Okay, 16-bit. 16-bit is only for program memory. Flash memory is 16-bit. Data memory, the GPR, the SRAM, they are all 8 bits. Okay, 8 bits. 16 bits is not, right? 32-bit is not, right? 64 is way wrong. List the registers used to save the pointer of data memory. The registers used to save the pointer memory is X, Y, Z. Oh man, so many of you. Oh, somebody got it right. X, Y, Z. One person clearly understand that, right? X, Y, Z. Maybe some. Okay, I see X, Y, Z. Okay, good. X, Y, Z. Many understand it as a step pointer. That is not step pointer. Step pointer is not used here, but that one is used in the RAM. Step pointer is in RAM. Okay, later on I will tell you about that. But the keyword here is the pointer. Okay, the pointer of data memory. So it's clearly XYZ. Okay, guys. This is to conclude. So I'll stop sharing for this one.
Doctor, are these quizzes counted in the carry marks?
I will tell you when I calculate. For this, so far we don't use it as a carry marks, but I use it as an attendance. I told you, right? About attendance. Okay. Until further notice, when I say this is for calculated into this one, then we do it. But it's important for you guys to understand that, as I said, 80%, meaning that you can only miss 9-hour class. Okay, so if it's more, when we reach 9-hour class, I will check. Okay, I will check the attendance based on based on your responses. Then I will issue some reminder. If not, then I will continue to remove you guys from the section. Okay, so those who do not respond or something, so please be aware of that. Right? So
Doctor, can we record the classes from the next class?
Can we what? I can
record the classes from the next class.
Record. Well,
record the session.
For the next class. Yes, you can record it, but for attendance, okay, yeah, you can do it. Okay, but the quizzes I will only accept during this time. Okay, during the class time. Okay,
yes, I know, but just for the explanation and the session itself.
Yeah, sure. I actually forgot to do that. I supposed to do that, but I forgot. Thank you. If maybe if anybody is willing to co-host with me, maybe that guy also can what do you call it? Can record, right? I don't know if there's a setting here that we can co-host, so you can also record. If I forgot. Is there anybody who is willing to be a host so that when I join, I just present, but he can record and then he can share with you with the others. So maybe we need to appoint a class leader to do this. Okay. Anyway, so it's one more minute to go. I just want to tell you that, guys, that I will post something in your e-learning. Okay, so please check that by today, by this evening. It's about your homework. Okay, your homework. It's about your homework for next class. Okay, addressing modes. So before we come to our next class, please check your e-learning, what to do. Okay, and and we will discuss that whatever you have done for your homework during that class. Okay. Okay, so with that, I understand you guys have class. So okay, I will end this now. As usual, if you have, if somebody has question, you can stay because I allocate this for discussion. Okay, the rest can leave if you have class. Okay. All right. Thank you. All right. Welcome.